Now, what is a methyl shift? Well, just like the hydride shift, it happens when we have a quaternary carbon next to our leaving group. So in this situation, we have an Sn1 mechanism because of the water and the heat, and we have this secondary carbon because it has two carbon bonds, and our leaving group, which is iodine. And then our neighbor over here has up to 4 carbon bonds, and so that makes it a quaternary carbon. Now, since this iodide or iodine is going to leave on its own using the Sn1 mechanism and take a pair of electrons with it and become negatively charged, we get left with a secondary carbocation on our secondary carbon. Now, what our neighbor can do right here, this carbon right here, it can actually take the bond that it has with our alpha carbon, right, like this one, and after it takes it, it bonds to the carbocation. And so you get an intermediate like this, where now our quaternary carbon is no longer quaternary, but now tertiary. And so you'll see this in just a second. And so there's our carbon that moved. And make sure we label our hydrogens that were clearly there with just lines. And so now we have a tertiary carbocation, which is more stable than a secondary. And so only after that happens can oxygen act like a weak nucleophile and attack that carbocation. And so we get this product, which is this right here, where we have a tertiary alcohol. Now notice I removed one of the hydrogens simply because when water attaches, it has 2 hydrogen bonds, and so it removes one of them because it's very acidic. And so this is our final product.